Let's talk about one of the biggest, most talked about topics out there right now, artificial intelligence. You hear about it everywhere, right? So today, we're going to cut through all that noise and get right to the heart of it. What AI really is, how we got here, and what the future might actually look like.
So, where do we even begin? Well, let's start with the most basic question you can ask. What is artificial intelligence? And it sounds like it should have a simple answer, but people have been arguing about this for more than 50 years.
And this quote, this is a great place to start. It comes from John McCarthy way back in 1956, from the actual workshop where the term artificial intelligence was born. I mean, this is ground zero. And I love this definition because it's so clear, right? It's the science and engineering of making smart machines. It's all about building things that can do stuff, that can achieve goals. It's simple, but man, it's a really powerful idea.
Okay, but here's where things get a little more complicated. It turns out, making intelligent machines isn't a single target. Over the years, researchers have actually been aiming at 4 different goals, each with its own take on what intelligent even means.
So check out this grid. It really breaks it down nicely. You've got 2 main questions. First, on one axis, are we trying to build something that thinks or something that acts? And then on the other axis, is the goal to be just like a human, with all our messy, brilliant weirdness, or to be perfectly, flawlessly rational? And when you cross those, boom, you get 4 completely different flavors of AI. You've got everything from trying to copy the human mind to building a machine that's pure logic.
Let's take that acting humanly box for a second. That's where the famous Turing Test comes from. The idea is pretty wild. Imagine you're texting with 2 others, but you don't know that one is a person and one is a computer. If you can't tell which is which, well, the computer passes the test. It's all about faking it till you make it, basically. A really cool idea.
But here's the thing. That's not really what most AI research is about anymore. It's not about playing imitation games or trying to fool people. The real focus has shifted to just building systems that can solve problems. So why the change? Why did they stop trying to perfectly copy us?
Well, this quote just nails it. Think about airplanes. The goal was artificial flight, right? But we didn't get there by building a giant mechanical bird that flaps its wings. No way. We got there when engineers stopped trying to copy pigeons and started studying the actual principles of flight. Aerodynamics, lift, thrust. And it's the exact same story with AI. The big breakthroughs came when we stopped focusing on perfectly imitating humans and started digging into the fundamentals of intelligence itself.
So let's talk about how that shift actually happened. It takes us right into the history of AI, which, let me tell you, has been a total roller coaster ride. We're talking massive highs of optimism, followed by some pretty brutal, humbling lows.
You can really see that roller coaster on this timeline. Back in '56, when AI was officially born, the pioneers were so optimistic, they thought they'd have human-level AI within a decade. Yeah, that didn't happen. The problems turned out to be way, way harder than anyone thought, and that led to the AI winter in the '70s, where funding just dried up. But the field didn't die. It came back in the '80s, smarter this time, with a new focus on machine learning. And that set the stage for the absolute explosion of deep learning that we're all experiencing right now.
Okay, so that brings us to today. What does this deep learning revolution actually look like? Well, its impact is literally all around us. And it's all thanks to 2 main things. Just unbelievable amounts of data and some seriously mind-boggling computing power. I mean, just look at this number. It's kind of insane. Since 2012, the computing power used to train the biggest AI models has gone up by more than 300,000 times. Let that sink in. 300,000! That means the power has been doubling about every 3.5 months. It's an explosion of power that's almost impossible to comprehend.
So what do you get when you throw all that power at a problem? Well, here's a perfect example: recognizing images. Back in 2010, the best AI systems made mistakes about 28% of the time. Not great. But look at 2017. The error rate dropped all the way down to just 2%. And get this, that's actually better than what most humans can do.
And it's not just about looking at pictures. I mean, this list is just wild. We've got AI beating the best humans at super complex games like chess and Go. Okay, maybe we expected that. But then you see things like protein folding, a huge scientific challenge, and even diagnosing things like skin cancer. The list just keeps growing. AI is becoming superhuman in more and more areas.
Okay, so all this incredible power, this superhuman performance, it leads us to the biggest question of all. Where are we going with this? As these AI systems get smarter and more independent, we run into some really profound new challenges.
One of the biggest challenges is something called the value alignment problem.
And what that really boils down to is this. How do we make sure that an AI's goals are the same as our goals? How do we make sure that what we ask it to do is what we truly want? It sounds straightforward, but this might be the single hardest problem we have to solve.
There's a perfect analogy for this. The King Midas problem. Remember that story? The king wished for everything he touched to turn to gold, and he got his wish exactly as he stated it. The objective was met perfectly, but then he couldn't eat, he couldn't drink, and he tragically turned his own daughter into a golden statue. He got what he asked for, not what he wanted.
And that's the core of it. We have to be incredibly careful that the goal we program into a machine is the goal we actually want. There's this famous thought experiment. If you tell a super intelligent AI to just make as many paper clips as possible, it might do that by turning the entire planet and everything on it, including us, into paper clips. It's not evil, it's just doing its job, literally, and with terrifying efficiency.
So it all comes down to this question from Norbert Wiener, one of the original computing pioneers. How do we ensure the purpose put into the machine is the purpose which we really desire? And you realize that's not just a technical problem for programmers to solve. It's a deeply human question. It forces us to ask ourselves, what do we value? What kind of future do we actually want? Because figuring that out might just be the most important thing we ever do.